Hey guys, welcome back. We just fixed 2A. Now we're going to fix 2B. Let's take a look. But first, I just want to remind you how I got to this website. So if you notice, I go to Google, type in norm CDF, and this website, Online Stat Book, is the one that I'm using today. There's lots of different ones, but this is one that seems pretty useful. Okay, and it will be useful on a couple of questions. So it says, for the density curve, what is true? So we notice that this is what normal looks like, and this is not bell-shaped. It's just mound shape. So this is not true. It can't be normal, but it is symmetrical, right? When we fold it in half, the left is equal to the right, okay? For the density curve above, what is true? The mean would be equal to the median, right? So the mean, when the mean is greater than the median, that's when it is skewed right, and less than would be skewed left. And so we know our answer is C. All right, next question, it says, suppose a 16-ounce bag of cookies was produced with weight that followed a normal distribution. The mean was this, and the standard deviation was that. Okay, so in our chart here, we can say the mean is 16.1 and the standard deviation is 0.1. All right, now it says, what percent of the bags will contain 0.60 to 0.61? All right, so between 0.60 and 0.61. 16.0. 16.1. All right. And we see on there, yep, it's coloring between 16.0 and 16.1, and it says the area is 0.34. Okay, so this 16 is incorrect. And our answer is 34%. So what happened here? Well, this is correct, but it looks like you found this found all of the area. And in order to do it by hand, which you didn't have to on the multiple choice, you'd find at 16.1, using this method, you'd find all the area to the left. And then you'd have to subtract off this tail. So you'd find all the area there, and then you'd have to subtract that off to find this area in between. So if I look at this picture, again, if you did it by hand, you'd find all of the area to the left of 16.1 using your formula for a z-score and looking in table A. Then you'd have to remember to subtract off this area to the left of 16 if you did it by hand. All right, what about question 4? It says, this is a continuation of 3. Approximately what percent of the bag would likely be underweight, meaning what percent is less than 16 ounces? All right, so less than 16 ounces. We can type in 16, and it tells us about 16%. So see, my image above is helping me know for sure that it is less than 16. And a weird twist of fate, it's actually the number 16%. All right. Notice this student did it by hand, and this is good. Very, very low number, 16. There's the mean, there's the standard deviation. She got the answer. It's perfect. Now looking at question number 5, the plot shown at the right is a normal probability plot. So we notice our main thing is if it's straight, then it's normal. So it's obviously not straight. So let's think about these values. If I think about a distribution, it looks like a lot of the data is coming in toward the lower x values. See how it's like dot, 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 dot. So that means dot, 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 dot. A lot of the data is coming in at the lower x values, and then fewer data is coming in as the x values get higher. So you notice if I took this data and made a histogram, it would look like this. That's not skewed left. Excuse me, that's skewed right. So skewed right data has lots of data at lower x values, right? Lots of data at the lower x values, and fewer data above, fewer data at higher X values. All right, cool. Let's keep going. It says, which of the following would be true? So we know that all, the area under a normal curve is always 1. That's how we're able to figure out what percentage this is. So if I said, what's the area between, I'm just gonna go all the way out there, right, to like 15.8. It looks like I'm going almost all the way out, 3 standard deviations to the left. And then if I go all the way out, it doesn't give me a value, but I'm just gonna go to like 17, all the way to the right. It shades everything, and notice that the probability is getting really, really close to 1, okay? So the area under a normal curve is 1, regardless of the mean and standard deviation. That's exactly right. If I change this to mean 0 and standard deviation of 1, and then just put, again, really low numbers and really big numbers, you notice the area under the curve is 1, regardless of what the mean and standard deviation is. The mean is always equal to the median. That would be true. The interquartile range. Ooh, okay, so this person got almost everything right, but just 1 and 2. And it looks like they circled it and then changed their mind. The interquartile range is from sigma -1, sigma +1. Remember with our flip grid, 1 standard deviation to the left and the right is 68% of the data, right? The interquartile range of a box plot, this is the inner 50% of the data. So they kind of tricked you there because the interquartile, 50 and 68% are not the same number, okay? Again, if I standardize this and I said between +1 and -1 standard deviation, +1, I calculate this. Notice it's a number close to 68, the area under the curve. That's not the inner quartile, the inner 50%. All right, now they're saying, which of the following is not correct about standard deviation? So we can put each of these in the table. Let's put in the one that the student circled. When is z greater than 2? Okay, so we standardize the graph, making sure mean and standard deviation are 0 and 1. So that's what z-score is. When would z be greater than 2? And when would z be greater than 2? It looks like it calculates it 2% of the time. And so this was circled, but this is true. You're supposed to find the one that's not true. So I think it's this last one. Let's try this one out. When would z be less than? Yeah, this one's actually one that you could maybe vet out without having to do every single one. If you think of this as -2.5, that's all the way over here, -2.5 z. And when would the area of z be greater? So that means the area under this curve to the right, this is going to be way bigger. So this one is the answer and E is false. Okay. Now let's prove it. If we come over here, when will it be greater or above -2.5? It looks like, yeah, a much bigger number than 0.49. All right, last one. It says in some courses, but certainly not in interest stats, students are graded on a normal curve. For example, students within a 0.5 standard deviation of the mean receive a C. So within a half of a standard deviation, receive a C. Between 0.5 and 1, they receive a C+. Between 1 and 1.5, a B. So between 1 and 1.5, that's a B. Between 1.5 and 2, that's a B+, et cetera, et cetera. The average on the exam was 60. So we know the number in the middle is 60, right? with a standard deviation of 10. Okay, so we can go back up here. We know the mean is 60 and a standard deviation is 10. Right? Now it says of the bounds for B, well, we know the bound for B is 1 and 1.5. So the bound for B is between 1 and 1.5. 1 and 1.5. All right, calculate. Oh, but it's like, oh, that's not the score. So you could figure out your score, right? 1 and 1.5. So 1 would be a 70, right? And 1.5, that'd be 75. So you already know the answer has to be, oops, this is wrong. The answer has to be this, but what would be the area of that, right? So 1 standard deviation above, if the standard deviation is 10, then 60 plus 10 is 70, and then a half, that'd be another 5. So we could play with this, but the interesting thing is you could have also double checked this. If I turn the mean back to 0 and I make the standard deviation 1, and it looks like I didn't make the mean 0, okay, turn the mean back to 0, and I say, well, what is the area of the curve between 1 and 1.5 standard deviations? And I get my answer, 9.19%. So we know that this is true, because that's true for the area under the curve has to be between 1 and 1.5 standard deviations. We could also plug this in to make you feel better about making it deal with the score. So if the mean is 60 and the standard deviation is 10, can we verify that between a score of a 70 and a 75 would be that area under the curve? There it is. And if we look at our chart, that's exactly what we were hoping to calculate. Thanks for joining me, guys. See you next time.